secrets. Wanna show you all my feelings.
Consider to get our table of values. Yes. Now, question says plot the graph of M and the vertical axis against T2 minus T1. Secondly, evaluate k equal to 50 over slope. We say that a solid mass 100 gram at a temperature of this is placed in 100 gram of water at 20 degrees Celsius in a calorimeter of negligible heat capacity. If the final steady temperature is 60 degrees Celsius, calculate the specific heat capacity of the solid. This is just additional question to what we have. Now, first thing you have to do is write the what date of your experiment. Then write the title of the experiment, which is a graph of what M in gram against T2 minus T1 in degrees Celsius. Once you are done with that, then looking at your values, label your Cartesian axis. This is M in gram. This is T2 minus T1 in degrees Celsius. We have this to be our what? The mass. Are you getting it? And we have T2 minus T1. The mass, the highest is 500. And T2 minus T1, the highest is 7.5. Wow. Now watch. I can say that here is 0, 0 because they did not instruct start from the origin or do not start from the origin. I will take anyone I prefer. 0, 0, 100, 200, 300, 400, 500. If you do not understand how to choose appropriate scale, please type Chidon's Daniel. Watch it. Chidon's Daniel, how to choose appropriate scale. Type Chidon's Daniel, then include how to choose appropriate scale. Chidon's Daniel, how to choose appropriate scale on YouTube. You'll see the video we have uploaded on that so that you will get yourself acquainted with how to do that. Okay. Then coming to T2 minus T1. Do you notice that as this one is increasing, this one is decreasing? That means we will have a negative graph. We have a negative. The highest is 7.5 and the lowest is 1.6. Wow. 1, 2, 3, 4, 5, 6, 7. We have 7. 1, 2, 3, 4, 5, 6, 7. So if I come and I put 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, 7.0, it will not accommodate 7.5. It will not accommodate 7.5. So what I will do is that I will use 1.5, 1.5, 3.0, 4.5, 6.0, 7.5, 9 point what? 5. So that is okay. 7.5, 9.0, please. This is 9.0. Wow, we can go by this one. Then we are plotting 100 against 7.5. 100 against 7.5. We will also plot 200 against the mass of water is what we are considering. 200 against 3.9. This is 3. This is 4.5. 4.5 minus 3.9. This 4.5 minus 3.0 all over 10. If here is 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. If here is 10 boxes all over 10, that will be giving you 1.5 over 10 equal to 0.15. Wow. This is 3.0. We are looking for 3.9. 3.9. So 3.15, 3.3, 3.45, 3.6, 3.75, 3.9. So at this point, we take it up to these two. We have been able to get the each of the balls to be 0.15, so we'll be counting it to get our 3.9. Are you getting it? 2.7 against 300. 0. We go to 1.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2.7 and this. Okay, watch what I will do. 0.15 times 5 will give me what? 0.75 plus 1.5. That will be giving me 2.25. I'm looking for 2.7. Well, I say 0.15 times, I will change from 5 to about 8. 1.2. 1.2 plus 1.5. That will be 2.7. Wow. So 8 at the 8. I'll take it up. So I'll count till 8. I'll take it up to what? Here. And put it. Then I will go again. 2 against 400. 0.15 times 5 gave me this plus 1.5. 2.25. And I am looking for 2.0. 0.15 times 2. 0.3 plus 1.5. That is 1.8. No. 0.15 times 4 plus 1.5. That will be giving 2.1. So that 2.0, we will be taking about 2.1. 1, 2, 3, 4. In between 3 and 4 is where we will locate it. Then 1.6 against 500. 0.15 plus 1.5. 1.65. So that means in between the 1.5 and the next small line, we put it here. So we have noted this now. The next thing you have to do is to use your broom or French curve and locate it. Use broom or French curve to locate it. Use broom or French curve to do what? Locate it. It should go in terms of curve. Are you getting it? So here are the points. Yes. Don't use free hand. Just use broom so that you have a perfect what? Curve. Then when you locate the perfect curve, they ask you to get slope. Ordinary, you can't get a slope of a what? Curve. What you get is gradient. Ordinary, you are not meant to get slope of a curve. What you get is gradient. Are you getting it? Every curve, you want to get gradient. Gradient simply means slope at a particular point on a curve. But because they instructed we are to get the what? Slope. All you just need to do is to check the what? The peak of the what? Curve. The peak of it. Check the peak of it and put your ruler. Draw your what? Straight line or line of best fit on that peak of that what? Curve. We have noted that because this is in a curve way, we cannot plot the mean of this and the mean of the, they cannot intersect because this is a curve. Are you getting it? So you will not do that. That is why what you just do is take a line that will touch the what? Apex of this curve. Look at, if you have a curve like this, the apex is where the line should pass through. you have a curve. If you have a curve, you just get the apex. You get the apex of it. That is what I mean. Get the apex of it and get your slope. That your slope will be negative. Obviously, it will be negative. How? You say take line from here to here and to what? To here. You now notice that here is 400. 500 divided by 400. 500 minus 400 is 100 divided by 10, 10. So here can be 410. Change in mass. Change in mass. Here you'll be having change in mass all over change in temperature equals to here about 410 minus 100 all over where this vertical and horizontal meet will be your what? T2. Then the other one will be your T1. So we take care to be what? T2 minus T1, 1.5 minus here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So here should be about the second point. You have 0.15 times 2. This plus 4.5, right? 4.8. That will be giving you 410 minus 100 divided by bracket 1.5 minus 4.8. You will be having minus 93.94 gram per what? Degrees Celsius is in negative. So we have gotten our slope. We have gotten our slope to be minus 93.94 gram per. Remember that this is just a sketch of the graph. So use your standard graph. We'll take draw your what? Your curve using your broom or your French curve. Then make sure that this your line of best fit pass through the what? Apex of this curve. Please, it will not obey that rule of you get the mean of the and plot, because this is a curve. It's only when it is a straight line that you will what? Obey that rule. But because this is a curve, it doesn't obey that rule. Okay? And so we have gotten our slope. We say gram per what? Degrees Celsius. They say evaluate K equal to 50 over what? Slope. K will be equal to 50 over what is our slope? Minus 93.94. Minus 93. So we say gram per what? Celsius. So 50 divided by minus 93.94. That will be giving us minus 0.53. And the unit now will be degrees Celsius per what? Per gram. Because inverse of this is what? Degrees Celsius per gram. Whatever you get from your slope, are you getting from the line you draw to touch the what? To pass through the apex. To pass through the apex of the curve. The apex of the curve. Whatever you get from that slope, evaluate it here. Remember I said ordinarily, any curve, you don't get a slope from a curve. Ordinarily, you don't get a slope from a curve. But because they say get a slope, the only way you can get a slope from this curve is by drawing a straight line to pass through the apex of the curve. Every curve has its apex. So the straight line have to pass through that apex. Once you just pass through it, get your change in this over change in this, and you get this is change in what? T. Get the change and divide. Whatever it gives you becomes your slope. The slope have to be negative. Are you getting it? So we have gotten the graph this value of K. We go to question number I. They gave us that a solid mass, this mass of the solid is 100 gram, equal to 0.1 kilogram. Why are we converting it to kilogram? Because SI unit of the constant given to you is in kilogram. Now, the temperature of the mass, the temperature of the solid is equal to 90. That is very hot. Now it's placed inside 100 gram of water at 20 degrees Celsius. Mass of water equal to 0.1 kg. Then the initial temperature of it, T1 is equal to what? 20 degrees Celsius. If the final temperature is 60, wow, final temperature is equal to 60 degrees Celsius. Calculate the specific heat capacity of the solid, given that, okay, in solving question on heat, we say heat loss equal to heat gain. Heat loss by what? Heat loss by what? That hot what? Hot mass equals to heat gain by what? Water. Are you getting it? And so we say mass of the what? The still. See, mass of the what? The solid. C of the solid bracket. The solid will be losing the temperature, which we call Ts. It will be losing the temperature as I just demonstrated in the starting part of the video. The Ts minus T2 equals to mass of water, C of water, T2 minus T1. Are you getting it? We are looking for Cs. Cs equals to MWCW T2 minus T1 all over MS bracket T2 Ts minus T2. What is mass of water? 0.1. C of water is 4200. Bracket T2 is 60 minus T1 is 20. All over mass of the solid is 0.1 bracket 90 minus what? 60, as the formula tells us. So we check it in our calculator. We say 0.1 times 4200 times 40 divided by bracket 0.1 times what? 30 equals to, that will be giving us 5600 joule per kilogram per watt Kelvin, and it is equivalent to 5.6. Okay, no more conversions, it's already is in kilogram per Kelvin. So you can say 5.6 times 10 raised power of 3 joule per kilogram per Kelvin. So that is how to perform this experiment. I've demonstrated how to get your values, so to speak. Yes, if you find this video very interesting, please don't forget to like it, click subscribe, comment, and share to your friends. See you in the next practical physics.